Greenland. A vast territory 80% covered by a glacial ice cap and the second largest freshwater reserve in the world. Here the effects of global warming are taking their toll, as the ice is melting faster and faster with each passing day. My name is Everard Wedenbaum. I've been leading expeditions in extreme environments for 20 years. Like many people, I'm concerned about the state of our planet. So I decided to lead a scientific mission in this region, which is particularly isolated and crisscrossed with gigantic glaciers. Together with a team of adventurers and researchers, our aim is to study the shifting and disintegration of glaciers. We want to understand why everything is happening faster here in the Greenland ice cap. In short, listen to what the ice has to say. We've just arrived here, on the east coast of Greenland, the far end of Scoresby Sund, one of the largest fjord systems in the world. The last Inuit village, untouched, is 10 hours from here by speedboat. We're going to cross the Renland Peninsula, 100 kilometers of never-explored Great Lakes, tundra, rivers, and glaciers. We're off for 50 days of expedition. Before our Inuit guide returns to his village, we take advantage of his small boat in good weather conditions to find a nearby iceberg where we can test our equipment. We need to find one that's large and flat enough to climb up on. It shifted. That was a big one. Our plan is to study the inner mechanics of icebergs using new scientific procedures, which require getting up to these huge ice structures. We can see the striae. When you look at the sides of the iceberg in front of us, you can see a couple of striae that are on an incline, which show it's already broken and has started to tip, probably several times. There's always a risk. It could break at two in any moment. We never really know. Wow, it's really beautiful. It's not easy to find a glacier stable enough for us to climb on and study for hours at a time. This should be good.
I know you like to carry things, but come on. I'll give you a little slack.
Try to keep it out of the water if possible. Where are the ice pigs? Oh, boy.
Well, then. Is this a good idea?
Too dangerous, or what do you think?
What cool.
Really, no matter the iceberg, there's always a chance it cracks.
I think so too.
Trouble is, there's no such thing as a stable iceberg. They crack without warning. They flip. It's like Russian roulette. But they're so massive and beautiful that you just want to climb them. It's been my dream since I was a kid. It's beautiful. The countdown begins. We know we can't stay too long on such unpredictable ground. I'm quickly joined by the scientists.
Not a bad office view. I'd say we have it pretty good right now. Go, go, go left. A little to the left. Go to the end of the rope. Very good. Keep going. How much is that? Stop!
We have a lot of sensors, so we're making 2 lines in an L shape. There's a sensor there, and we already placed 6 on that line. So every 10 meters, we'll make a hole with a pin to set the geophone. This red sensor.
Everything's ready. We just have to set up. I'm holding a dozen geophones that will record all the mini vibrations of this. Holy cow. Stop.
We're going to log all the iceberg's cracks with these small sensors. With help from Agnes and Everard, we're placing them on the iceberg. They'll capture all the vibrations up and down the ice. It's constantly vibrating. We hear cracks all the time. It's really cool. We can really tell there's something happening every minute on this iceberg. And we'll be able to record all of that in this box, which has a huge sound card. It's like a sound card with 24 microphones, each connected to a sensor. These microphones allow us to pinpoint the source of the sound, so we know if the cracks are always coming from the same place. Knowing whether the cracks come from here or from there will really help us understand how the glacier works. I'm personally interested in understanding how all that resonates. The sound within the iceberg should resonate like sound in an ice cathedral. When you make noise in a cathedral, there's a powerful, long-lasting echo, and this iceberg should display a similar effect. When it cracks somewhere, that echoes and resonates throughout the entire iceberg. We should be able to record that, which I don't think has ever been done. All set.
What's new is our study of seismic waves caused by the icebergs fracturing. We'll be able to tell if it's the waves, the tides, or the air or water temperatures that are weakening the iceberg and causing it to recede. Our first camp is on the waterfront, not far from the glaciers. The ice flow is retreated here, making this polar bear territory. We'll do everything we can not to disturb them, but they could get curious. Time for a quick lesson for those who aren't familiar with guns.
You see, it's red there, so you can fire.
Oh, God. But why does it automatically do that? It's on, off, on, off.
Now it's on.
Now it's on. If a huge bear suddenly appears, I'll just panic. Do you really think I'm going to worry about my aiming and my position?
Bears just don't run at you from 300 meters away. They approach slowly. They stop, sniff, then they move again, you know?
Can't we just yell or run away?
No, don't run.
Can't we do something else before shooting?
Lots of things. Shooting's a last resort.
Okay, like what?
First, try the flare.
Try the flare, okay.
Then you try shooting, but shoot next to the bear, not at it.
Oh, I'd miss him anyway.
Good, even better then.
Which eye
Hold
do I
on.
close again? The left or the right?
Like that, but don't stretch your arms. Tighten up.
Okay, like this. Bye. Oh. Oh, gosh.
I think the bear will die of laughter.
We had been dreaming of the day we could explore this corner of the Arctic and carry out our science projects. But we had to wait for the ice floe to leave the fjord. Now we have just under 2 months to get the job done, and it hit us hard right at the start. The countryside, the noises, the animals, the skies, the lights, it's all powerful here. Before climbing the glaciers, I want to see some of the tundra's wild fauna. The natural tundra here in Greenland covers a land the size of Germany. See there? That's one right there. Fabulous creatures live here, and it's not always easy to study them. It would be cool if he came this way. Look at that one, with a broken horn. He's gorgeous. It's crazy how resistant these animals are. They go everywhere. They climb super steep ridges. They walk on ice. They swim. They can do everything. Musk oxen have no problem with the cold, but they're very sensitive to heat, even after shedding their winter coat. As soon as the temperatures exceed 10 degrees Celsius, it can be fatal. Sadly, this happens more and more. Yet another animal that doesn't appreciate our lifestyle. According to the Inuit, it's a foul-tempered creature that's potentially even more dangerous than polar bears. Amazing. He's beautiful. The other day, I got really close to one, even closer than this. He wasn't paying attention, and he only noticed me when I showed myself. And he turned towards me and looked me straight in the eye. We stared at each other for a while. I sensed he wasn't going to back down, so I pulled back and moved away. 300 kilos is a big animal. I wouldn't want to be impaled. From our camp on the water's edge, we'll have to go deep into the Renland interior, climb the giant Apus Inikajik Glacier, and attempt to get to this very undetailed part of the map. But before implicating the entire team, I'm going out on my own to scout for crevices. Okay, so I'll map the itinerary through the middle of this glacier and its crevices. It's a maze of constant danger in there. But I have no choice. All glaciers are like this. I have to admit, these types of obstacles are what keep the adventure exciting. If it was too easy, it would be boring. But I'm not sure everyone on the team feels the way I do, especially when carrying heavy loads. We packed for 10 days of hiking with scientific gear, food, ropes, crampons, our shelter. Some have over 40 kilos on their backs. Since I want everyone to come, that means carrying a lot of weight, which takes considerable effort. No one really likes to do it, but I know some people will carry a bit more to help those who will end up carrying a little bit less. But I think it's a great learning opportunity. You learn that if you want to be more generous and help someone, you can do more than just give them things. And you can give your strength and your energy. But I know it's not an easy choice to make, because you can never really please everyone. You see the moraine deposits and the big pile of rocks over there? It's not stable at all. And when you're carrying a big bag like today, it's really dangerous. You can get hurt really quickly. Some people are okay with that and others are not. So segments like this one, which is tiny compared to the distances we've covered, actually take a lot of time. We left around 1 p.m. and it's now 10:30 p.m., so we've been on the move for 9.5 hours. A helicopter from Itakko could have dropped us here in an hour. But the thing is, we wanted to be ethical about this whole expedition, so we decided to go by foot. That's great, Gael. Well done. Nice. But we're also here to experience something for ourselves, to experience it in our own way. And our way is the way of nature, so we're not going to just lumber in here like fools. We're making an effort to be as frugal as possible and to be in harmony with our environment. That harmony is best embodied by Aurélie, our illustrator. She follows us every day and then disappears as stealthily as an Arctic fox, to sit somewhere and draw for hours. When she reappears, you can feel the serenity radiating from her, and it encompasses everything. Now we're here in the heart of the Renland Mountains. We're looking for a small hill that we hope will give us some geological clues about the region's past. For the second time, I'll scout the terrain ahead of the group, as the hill we seek lies in the middle of a frozen lake that's 10 kilometers wide and full of icebergs. They're packed tight against one another. I hope to find a passage through the clusters a bit further ahead. The bad news is there's no open water, only ice. So I can't go very far. This is all ice. I can't get through. And I risk puncturing my boat if I insist. Move on, move on. Come on, move on, move on. I'm pushing the icebergs. I'm so happy to see this. That was quite tricky.
Ça s'est joué à pas grand-chose, hein.
We've entered a lost world, a place where no one has ever set foot before. Now that I know we can get through, I'm back with Eric LaRose, our seismologist. The discovery of this lake, sandwiched between two glaciers, makes us wonder. That's strange. We can't see any outlet. There's no river or stream, but yet the water has to go somewhere. But where? Under which of the glaciers? It's a mystery. Look, it's muskox fur. They must be not far, because these traces are fresh. They could be just around the corner. We're looking for traces of the past here on this mini island. Thousands of years ago, during the last glaciation, this glacier must have been much thicker than it is now. It was about 1,000 meters taller. I suspect it covered this entire hill, and it carved away the rock over thousands of years. So we're going to analyze the striae, the glacier left behind, to see which way it's flowing. Thousands of years ago, the glacier was flowing in the opposite direction. That means that in the same valley, in two different periods, one glacier was going one way and another glacier was going the other way. That's a pretty incredible discovery. Now we're walking on the last vestiges of a glacier, which changed directions many times based on climatic conditions. Who knows what this place will look like if the temperature rises a few more degrees. We made it to Edward Bailey, one of the biggest glaciers on the Scoresby Sund. One of our primary goals is to study the connection between the meltwater and the speed at which a glacier moves. We're looking for a way in. The best way is to follow the rivers. My goodness, this is like
Waterworld?
Waterworld, the Eskimo version. All right, here we go. This is sick. Wow, incredible. Oh, be careful. Other side, other side. There.
You okay?
Yeah.
I'm coming. Wait. Shit.
After the collision, I managed to get free. But Eric's pack raft is full of water and he can't move. We have to empty it.
Try to lift it.
I can't, it's too heavy.
The increasingly strong current complicates the situation. But he gets help and manages to get moving again. This is crazy. We're at the end of the world, on an enormous glacial river. It's clearly the biggest glacial river I've ever seen. And somehow the meanders are just the right size for us to go downstream. The river runs like a giant snake carved into the glacier's surface. It's over 60 kilometers long. There are actually thousands of meltwater streams that flow from the glacier, slowly draining it of its waters. All this water must find its way to a crevice at some point or another, where it surges in, carving out a vertical shaft. They're called glacier mills. They're mysterious and dangerous, and we've come to study them. You let the sound guide you, and as you get closer, you feel it, and suddenly, it's right there in front of you. It's spectacular. It attracts you, but at the same time, it's also dangerous. I find it very exciting. You just want to get closer and closer. I'm happy I got out of the boat before arriving here. It's a little nerve-shattering. The force of the water is incredible. Anything floating in it flows into that hole and comes out 12 kilometers away, at the end of the glacier. What's funny is, here the water is very clean. It's totally clear. While in the valley below, at the end of the glacier, it's a river of mud. Most glaciers aren't actually on a bed of rock. Rather, they sit on top of sediment. So once the water reaches the glacier's base, it becomes totally brown. That's where we need to go, but not today.
Want chives with that?
Yes, I got them out. Oh my God, I pity the vegetarians. They only have white rice.
This is making me hungry. Totally.
Oh, crap.
I know. That one's for you.
You're eating that one. Don't waste anything. Think of the others.
No one has water?
Just put it back in. Excellent. Cheese, sausage, rice.
This is the best meal I've ever had.
Ours was a little crunchier.
Wait, where is it? There? After scouting this site with a small team, I reassure the scientists. Countless glacial mills punctuate the glacier, and one of them looks perfect for our study. We saw a great one near here. It was perfect. I think this one will be the easiest to access. It's really beautiful, like stunning.
So we can go down, but we won't go too deep. So we won't need lights?
No, it's very blue, very bright and big.
Is it full of water down there?
There's a lake.
Okay, got it. This should be cool.
Our plan is to slip down inside the glacier and set up our instruments. We have to take lots of things into account. The entry, the flow, the depth, the width. We're sure to discover endless twists and turns that result from the glacier's movement. Because while they seem very stable, some glaciers advance several meters a day.
This glacier mill is particularly interesting because water flows here all day, so we can measure the amount of runoff. Additionally, it's big enough for us to get inside, so we'll be able to go to the bottom and see what's really happening in the heart of the glacier. Descending a glacial mill is a delicate mix of spelunking and ice climbing. As long as the ropes are attached to safe and solid anchor points in the ice, there's no risk during the descent. But if a single one of the rope's anchor points is weak, the risk is huge. You can't afford to fall into a glacial mill. The water would quickly suck you beneath the ice, and there's absolutely no chance you'd come out alive. I'm precisely measuring the water levels with this tool, which also measures the temperature at a few different depths. That will allow us to take a good reading of this glacier. Some glaciers read at 0 degrees and others are below 0. What's unique about the glaciers of Greenland is that they manage to stay very cold even though they're at low altitudes. It's interesting to see these glaciers here, as they're like what you'd normally find in the Alps at high altitudes of 4,000 meters. So they're special and they break very easily. We're studying all that.
So what we're doing right now is digging a small recess where we'll place the seismic sensor. Is that it?
Exactly. And thanks to this mill, we'll be able to record the deepest of the glacier's vibrations. This is really a first. So we're going to place the sensor here in this recess. The sensor acts like a microphone, but instead of recording sound in the air, it records echoes in the ice. It will measure the vertical vibrations of the ice, everything that vibrates along this line. Our job after the fact will be to analyze those recordings in the lab, to translate those vibrations, those whispers and echoes, into a representation of the glacier's inner mechanisms. The ice changes shape, it cracks, and this important week of research will give us enough to work on for at least a year.
This is an incredible journey to the center of the ice. But we're not stopping at the water's surface. In fact, we're going to take it to even further extremes. We want to know what's underneath the ice and where the water comes out. Wow, it's noisy. I'm soaked, but it's okay. Be careful, though. I heard a cracking. There were a couple of moments when I felt it went and everything started shaking, even the ice anchor. So I was like, oh crap, what's happening? It's scary. When you get in the water, you'd better be prepared for the loud sound of those cracks and be ready. But it's going to be beautiful. That's great, Laurent. Sit deep down into your harness. I asked Laurent Marie, a really good diver, to join our mission and attempt to explore underwater. No one has ever dared to do such a thing. Brace yourself directly to the cabinier. Let that thing go. Of course, he'll be attached to a rope underwater to make sure he doesn't get swept away.
At the bottom, the water was very cold. My depth gauge read the temperature at 1 degree Celsius. There was a drop-off that went down between 5 and 6 meters, so not too deep. And at the bottom, there was black sand. It was black sand that sparkled and swirled up from the waterfall, and all these sparkles floated around me like it was raining stars. And at that depth, it was calm. You couldn't hear the noise as loudly. Down at the bottom, it felt like I was floating in the stars, in the sparkles. It was totally crazy. Totally crazy. It's incredible. Amazing. It's amazing. There was no particular danger on the water's surface. However, at the bottom, where it got really difficult, was at the edge of this chasm. As I got closer to the bottom, it dropped off and I could feel the current pulling me towards the chasm. So I had to be really careful not to get caught in that, because we didn't even know where it came out. I was in another world, another universe, a universe of poetry and magic. It was a dream come true for me. It was something I never thought I'd be able to do, to free dive in a glacial mill.
That's good.
What an adventure.
What an experience. You okay?
Yeah, I'm okay.
That one worked.
Well, what do you think? Maybe?
Oh, yeah, not bad.
Maybe, maybe not.
I can't see anything. What are they doing?
They're playing.
Cool.
What about here?
We were testing the depth by throwing a rock.
After exploring the glacial mill, we're now going to better understand the water's course within one glacier. To do so, Eric and Agnès head towards the outlet of the Edward Bailey Glacier.
Great. Incredible. Beautiful. The river seems to pass beneath us, which is incredibly lucky, because we can follow it quite a long way without being in the water. That's really great. We start seeing beautiful blue color there. It's awesome. Can you get in here? It's magical. It's magical. Unreal. We're inside the glacier. We're underneath it. We need to be careful. There's a bit of a dip there. We have to make sure it's not a hole and that it's safe. It's still going. Holy crap, it's huge. Way! There's another cave over here. This never gets old. Incredible. Look at that ice tongue there. See it? It was totally deformed from the pressure, and then it froze over again. Yeah, great. I'll shine some light for you. This is under-ice spelunking. What we're doing right now isn't very common. Hey. I'm like a stuntman. What we're seeing is incredible. It's an ice palace. I've never seen such large ice crystals in my life. They're in all shapes, hexagons, cones, and those are drops. They're bigger than my thumb. They're all here. I've never seen anything like this. It's very cold inside the glacier. It must be -4, -5 degrees Celsius in this cave. The air's coming from the underground river. This air is very humid. The humidity will slowly coat the ice and then recondense for weeks and weeks. And the crystals will slowly grow, very slowly. And after a few months, you get giant crystals like these. They're giant crystals in a giant glacier. It's crazy. This alone makes the trip worth it. The ambience here is incredible. An underground river in the ice. There's a small underground river that began at the surface crevasse where the water fell through. And while it flows, it melts the glacier from the inside. And that's how this cave was formed, little by little, over the course of many years, or maybe in one season. And when summer is over and it starts getting cold again, the water stops flowing on the glacier's surface. So the water level drops in here and you can go deeper inside. It's a fun ride. We're going to tie the boats up, to be sure they don't float away in case the water level rises. It's like beautifully sculpted marble. The ice is so pure. It's extraordinary. It's ascending a bit. There's an exit over here. I can see light. I see light. We're out. Incredible. We're at the entrance to the tunnel that leads to the ice cave, and we can see light now. We've reached the scree, the end of it.
Their adventure to the center of the glacier went better than expected. But Agnès and Eric must remain alert. A glacier is a monster in constant movement. After 3 hours of exploring, they must be cautious and exit the cave. The change in decor is almost surreal. After emerging from the ice, they're on an immense sandy beach, and Eric and Agnes are struck by an intuition and ask me if we can stay to study this atypical terrain.
We thought we were crossing a sort of beach, a sandy zone at the base of the valley, and the crossing it would take half a day. But we ended up staying more than 3 days because beneath the layer of sand, which is blocked by a glacier downstream and a glacier upstream, it's a completely flat area. We quickly discovered traces of ice. By walking like this, we can probe beneath the ground of the entire valley. It means we don't need to dig a hole that would have needed to be 100 meters deep and 2 kilometers wide. It's magical. When we only have a few readings over just a few meters, we can't make anything of it. But after about 200 meters, shapes start appearing on the screen. And what I'm seeing, about 20 meters below, is a geological interface that's very strong, very clear. There are hills beneath the sand that are more than 10 meters high. We think it's ice, which is really good news for our experiment. 15 meters? So there's the sand, and that's the ice. This beach is not a beach, it's actually a glacier. There's a significant amount of ice that's trapped in the valley and no longer moving, because it's isolated by the sand. This glacier could be very old. It's a fossilized glacier. We don't know if it's been fossilized for a couple of 100 years, a couple of 1,000 years, or even tens of thousands of years, which would be truly exceptional. But one thing's for sure, we put this fossilized glacier on the map. We had to take the time to do this expedition by foot and take the time to stop at this place in order to discover this wonder.
We would have loved to stay longer. It was so beautiful. But we're running low on food, so we must head back to the fjord. We have to carry everything back to where it all began. Yes, tie it there. Pull a bit more. The problem is that the rivers are swollen. We can't cross carrying the bags. Falling in the water with your pack on and getting everything soaking wet is just unthinkable. It's barely 5 degrees Celsius outside. You'd never warm back up. This one's really heavy.
Yeah.
The zip line can only support the bag's weight, so we have to face the chilly water with as few clothes on as possible.
Thanks.
In the heart of our adventure in the Scoresby Sund, we alternated between exploration, carrying weight, and taking scientific readings. These readings will allow us to better understand the connection between climate change temperatures and the accelerating melting of the glaciers. This phenomenon doesn't only contribute to rising ocean levels, which we all know. It also contributes to the cooling of North Atlantic waters, which could eventually interrupt the Gulf Stream. Without these significant warm water currents, Europe is at risk of completely losing its mild climate.